Page 8, probably the longest page. One thing I'm going to need to have on hand is a periodic table, which I'm all set with. Molar masses. How much does a mole of something weigh? This is just check the periodic table. Copper, just find it. Copper's right there, 63.55. It says to include a unit, 63.55 grams. Calcium, find it. It's over here, 40.08 grams. I'm okay if you simply put 40 grams. The next one, strontium chloride, is 1 strontium and 2 chlorines. Got to go find strontium. It's over here, 87.62 or about 88. I'm going to say 1 strontium is 88 grams. 1 chlorine is 35.5 grams, so 2 chlorines is going to be 71. 2 times 35.5 is 71. So I'm saying that, but I didn't write it. 159 grams for strontium chloride. The next one, magnesium carbonate, I have to add up 1 magnesium, 2 carbons, and 2 times 3 is 6 oxygens. How much does a carbon weigh? 12. How much does an oxygen weigh? 16. I got to go to the chart. I got this here and here. Magnesium's over here, and it's 24.3. 124.3. So make sure we're multiplying, because this is going to be 24.3. 12 times 2 is 24. 16 times 6 is 96. 14.3, 5, 4, 6, 144.3. 144.3 grams. Just did a check. Some people got 128.3. To me, when I look at what it should be, 144, and when they got 128, 144 minus 128 is a difference of 16. It's like they're missing an oxygen. I'll bet you they added 3 plus 2 to get 5. I have to do 3 times 2 to get 6. Next one for the following problem. So the correct answer is 144.3. For the following problem, show all work, label units. How many grams is 7 moles of magnesium chloride? Well, you start with the same thing. You write down whatever they gave you. I like to put it over 1. That way I know that it's on top and it'll have to get crossed off. If I've got moles up top, I need moles of magnesium chloride on the bottom. What I really need to know is grams. So grams of magnesium chloride, as long as I can figure out the relationship. How much does 1 mole of magnesium chloride weigh? Well, 2 chlorines are 35.5 times 2 is 71. A magnesium is 24.3. And that equals 95.3 grams. 95.3 grams, that goes on top because I need moles to cross off. 7 times 95.3 equals 667 grams of magnesium chloride, or 0.1. I'm okay if we just round. How many molecules? Hint here, it's probably going to be a big old number. If I have 75 grams of H2SO4, I'm going to put that over 1. I don't want grams of H2SO4, so it's got to be on the bottom. I can't figure out how many molecules are in a gram. I don't know. I do know, though, the relationship between moles of H2SO4, or at least I can figure it out. I've got to add up 2 H's, 1 S, and 4 oxygens. 2 H's weigh 2 grams. 1 S is 32 grams. 4 oxygens times 16 is 64 grams. Whoops, that's a 4. So that's going to equal 98 grams. 98. Okay, I wrote it there, and then I see, wait, that says mole. I don't want mole, so I'm going to backtrack a little bit. 98 grams is 1 mole. Unfortunately, I'm not done with this, because grams and grams would cross out and leave me with moles. So how do I get rid of moles? It's got to go on the bottom. What do you know about moles versus molecules? Well, 1 mole of anything is 6.02 times 10 to the 23rd. Molecules are formula units, moles and moles. I have to do 75 times 6.02 times 10 to the 23rd divided by 98. I put that into another calculator and got 4.6 E23. I left a lot, I rounded a lot off. 4.6 E means times 10 to the 23rd. That would be molecules of H2SO4. Next one's a little bit of empirical versus molecular formula. Empirical is the simplest whole number ratio. It's as if it was reduced. Molecular is what's actually shown, or molecular is what's actually nature gives you. I see 2 carbons and 1, 2, 3, 4, 5, 6 H's. C2H6 is what's actually shown. That's the molecular formula. Or H6C2 is okay. But that's not the simplest whole number ratio. If it's a 2 to 6 ratio, that's the same as if it's a 6 to 2 ratio, that's the same as a 3 to 1 ratio. So CH3 is the simplest way of writing it. Next one. This one is simply an empirical formula. I like to look to see how many things I have to figure out. Looks like phosphorus something, chlorine something. So over here I have to figure out how many grams of phosphorus and how many grams of chlorine. Phosphorus is easy. They tell me it's 11.39 grams. Chlorine, I'm going to have to do some subtraction. If the whole sample weighs this, but only this much is phosphorus, I'll have to subtract 50.51 minus 11.39 to get 39.12 grams of chlorine. Next thing is dividing by its molar mass. How much does a mole of phosphorus weigh? Phosphorus is over here at about 31. Divided by 31. How much does a mole of chlorine weigh? 35.5 grams. When I put these into the calculator, I might decide to keep a few extra digits just so I don't make mistakes. 0.367 moles of P. I wouldn't round that off to 0.4, even though a lot of times I would. When I'm doing molecular formulas and empirical formulas, it's good to keep extra digits so that we get a really truer sense of the real ratio. Now I'm doing the bottom one, 39.12 divided by 35.5, and that's going to equal 1.10 moles of chlorine. So I'm looking at these ratios. I need to know the ratio of this stuff to this stuff. I need to divide. Best way to do this, in fact, this is what you need to do. Put the big number on top, 1.10. Make sure you label which substance that is. Put the little number on the bottom. Make sure you label which substance that is so that we know which is going to be which. When I do 1.10 divided by 0.367, I'm going to get pretty much an integer, 3. 3 chlorine was on top. It's a 3 to 1 ratio of P. So I would say PCl3. 3 chlorines, but just 1 phosphorus. The next one's both an empirical and a molecular, but the same idea. What am I trying to figure out? Carbons, hydrogens, and oxygens. So over here I can write down 6 grams carbon, 0.5 grams hydrogen, 2 grams oxygen. Divided by its molar mass. Carbon weighs 12 according to the periodic table. Hydrogen weighs 1. Oxygen weighs 16. This will give me 0.5 moles of carbon, 0.5 moles of hydrogen, but 0.125 moles of oxygen. And I'm looking for a mole ratio. And I'm still going to follow the same format, which is the big number. Well, it's a tie. They're both 0.5. Those are the big number. Those are C's and H's. Their number will be the same when I'm done, which is the smaller number, 0.125 moles of oxygen. This ends up being 4. That means 4 C's and H's for every 1 mole of O. C4H4O. That's only the empirical formula. To do the molecular, I've got to use this number. 1 mole of this stuff should weigh 136 grams per mole. What I've got to do is figure out if I did have 4 C's, 4 H's, and an O, how much would that weigh? 4 C's, 12 times 4 is 48 from the periodic table. 4 H's, 4 times 1 is 4, plus an oxygen, that's going to equal 68 grams per mole. How many times bigger is 136 than 68? 2, twice as much stuff. So I've got to keep the same ratio of 4 to 4 to 1, but instead of C4, I'm going to have twice as many, C8. Instead of H4, I'm going to have twice as many, H8. Instead of 1 oxygen, I'm going to have 2. This is the molecular formula.